Welcome back again to the H2O Spirit channel. Remember, there was a video I made on more concepts where I gave you all the formulas that are used in solving problems involving more concepts, and I promised to show you how these formulas are applied in solving questions involving more concepts in your forthcoming examination. Okay, now the question on the board says how many molecules of white phosphorus, and they gave us the formula of phosphorus. Remember that phosphorus is a polyatomic molecule, are contained in 248 grams of the substance. How many molecules? Please, this is not number of moles. No, they are looking for the number of molecules. Remember, I gave you formula for number of molecules, or number of atoms, or number of particles. These three statements are the same. And what is the formula? Whenever the question involves number of atoms, number of molecules, or number of particles, they have one single formula. So make sure you check the question very well so that you know the formula that should be applied. Now, the formula for number of molecules, remember in our previous video, please, if you have not watched the video where I gave the formulas for more concepts, you have to do that before you can understand this very well, except you already know the formulas before. Okay, so number of molecules is the same with number of atoms, or is the same with the number of particles. And what is the formula? The formula is very easy. Okay, the formula is number of atoms, which is Na, small letter, is equals to reacting mass, small letter, over the molar mass times your Avogadro's constant, capital letter. Like I told you, this is your Avogadro's constant, this is your mass, this is your molar mass. And again, remember that mass over molar mass signifies number of moles. So we can still say that our number of atoms or molecules or particles is number of moles, which is mass over molar mass, that is denoted as N, and times your Avogadro's constant, which is your Na. This is your Avogadro's constant, and that's what is giving us here, Avogadro's constant. Okay, why this one is your number of atoms, the same with number of molecules or number of particles. So this simple question tells us that this is the formula that should be used to solve the question. Okay, what do? How many molecules, that's what we are looking for, of phosphorus are contained in this? This is the mass. The mass M is 248 grams. That's the mass. Okay, now remember, what will be the molar mass of phosphorus? They gave us the relative atomic mass to be what? 31. Remember, I told you, if you are given relative atomic mass, remember this phosphorus is a polyatomic molecule, so it has 4 here, meaning that we are going to multiply the relative atomic mass 31 by 4. Okay, now if you multiply 31 by 4, you have 4 times 1, that will give us 4. 4 times 3 will give us 12. So you have 124 grams. Okay, now your Avogadro's constant is 6.02 times 10 raised to the power of what? 23 per mole. Now, our formula says number of atoms is equals to reacting mass. Okay, our reacting mass is 248. Okay, our molar mass, we have solved it now. Remember, they gave us 31, and it's a polyatomic atom. See it, there's 4 here. So use 4 to times it to get the molar mass, 124. So our number of molecules or number of atoms is reacting mass over molar mass times your Avogadro's constant. So what's the reacting mass? Very easy. It is 248. What is your molar mass? It is 124 times your Avogadro's constant. It is 6.02 times 10 raised to the power of 23. So what do we simply do? We are going to divide this by this, okay? We are going to divide 248 by 124. 248 divided by 124. Okay, that will give us, if you divide these two values, you are going to get 2 times 6.02 times 10 raised to power 23. If you multiply this, you are likely to get 2 times 1, 2. 2 times 2, you have 4. 2 times 0, you have 0. 2 times will give us 12 times 10 raised to the power of 23. So you can move your point from here to here and have 1.2 towards 0.4 times 10 raised to the power of 24 molecules. That's the answer to the question. So we have to go back to the option and see our answers. Option A is totally wrong. Option B is totally wrong. The answer is what? C. 1.204. Our answer is C. So we'll take another question. How many atoms of oxygen are present in 24 grams of ozone? How many atoms of oxygen, still on the mole concept and using the same formula that we used earlier than now, okay? Now, how many atoms of oxygen are present in 24 grams of what? Ozone. This is the mass, don't forget. This is the mass. So we can say that our mass is 24 grams. But the atom they are referring to is the atom of oxygen in ozone. And what is the formula of ozone? Ozone is an allotrope of oxygen that has a formula of O3. Just like I told you, whenever you are given the atomic mass of an atom, check whether or not it is the atomic, triatomic, or polyatomic so that you know the value you are using to multiply it. So as for ozone, you have O3. That will make the mass, the molar mass of ozone, O3, to be, remember oxygen is 16, so you have 16 times 3, and that will give us what? 48 grams. So we have the molar mass of ozone as 48. Remember, we are told to find the number of atoms. Same with the same formula. Number of atoms is reacting mass over molar mass times Avogadro's constant. Or your reacting mass over molar mass is number of moles times Avogadro's constant. So peradventure you were given number of moles, you would have multiplied with Avogadro's constant to get the number of atoms or number of molecules or number of particles. Okay, so let's do this. Our number of atoms they ask us to calculate is the reacting mass. What's the reacting mass? The reacting mass is 24. So you have 24 grams over what? 48 grams times Avogadro's constant 6.02 times 10 raised to power 23. Please do not fail these questions in your SSC and your JAM exam. They are very cheap. If you divide this by 24, you have 1. Divide, you have 2. So 1 over 2 will give us 0.5 times 6.02 times 10 raised to the power of 23. By the time you multiply 0.5 by 6.02, multiply just these two first. Don't multiply with this. Multiply just these two, you have 3.01 times 10 raised to the power 23 atoms. These are the number of oxygen atoms that is present in 24 grams of what? Ozone. So let's go back to the option. Option A say 4.5, totally wrong. Option B say 3.01. Our answer is what? B. We have another 2 questions to solve on more concept before we call it a day. Question number 3 is from PC 2007, number 5. That's your JAM. The old JAM. There was a JAM called Pixie. As at that time, UTME was organizing 2 exams. One was JAM was organizing 2 exams. One was PC and one was UTME. So this is also from JAM past question, PCE. Calculate the mass of chlorine gas which will occupy a volume of 1.12 dm cube at XTP. Remember the formula I told you about that has to do with the volume. I said if the question involved the volume of a gas evolved at STP, if volume was measured in a mole concept problem, you can solve it this way. Volume is equals to mass over molar mass times your gas molar volume. I told you your gas molar volume is the volume occupied by 1 mole of a gas at STP. And this your gas molar volume is 22.4 dm3. Is 22.4 dm3, okay? So your volume is mass over molar mass times your gas molar volume. That's what they gave us here. The volume occupied by 1 mole of a gas at what? Standard temperature and pressure. So you have volume is mass over molar mass times your gas molar volume. Or, just like I always told you, mass over molar mass is number of moles times your gas molar volume. So if it involves number of moles, you can just multiply directly. Now, how do we solve this very interesting and simple question? Calculate the mass. We are looking for mass of chlorine, which is this mass. So we'll say that our mass is unknown. Okay, did they give us the molar mass of chlorine? Yes. The molar mass of chlorine here is 35.5. Remember that chlorine is a diatomic gas. So you have to multiply with 2. I've told you every diatomic gas you multiply with 2, triatomic gas multiplied with 4, tetraatomic molecule or polyatomic multiplied with 4. You have Cl2, O2, H2, N2, O3, P4. So when you see polyatomic multiply with 4, triatomic multiply with 3. Okay? Now, if you multiply 35.5 times 2, you get 71 grams of chlorine. Now, what did they say is our gas molar volume? It is 22.4 dm3. Remember, it can be in dm3 or cm3. Then it becomes 22400 what? cm3. But we are not working with this because the volume in the question was given to us in what? dm3. So what do we do now? We are looking for the mass. So let's put our volume. Our volume in the question is 1.12. So you put it 1.12 equals to the mass. We are looking for the mass over molar mass. What's the molar mass? 71 times your gas molar volume 22.4. So what do we do? You can cross multiply here to give you 1.12 multiply with 71 equals to multiply this to 22.4 what? M. And then you divide both sides with 22.4 to get your M, 22.4. So this cancel this. Your mass will give you 1.12 times 71 divided by 22.4. Let's quickly use our calculator to do that. (1.12) times 71 divided by 22.4. You have 3.55 grams. 3.55 grams. So the mass of chlorine that is deposited is not A. If you check C, it's not C, it's not D. Your answer is what? B. So be careful. Please watch our previous video on mole concept. I dropped all the formulas necessary to solve problems in mole concept. We have one more question to go for this class before. Now this is our example 4. What volume of these molecules of carbon 4 oxide occupy at what? XTP. We are looking for volume of carbon 4 oxide of these particular molecules. What volume of these particular molecules or composer will occupy at STP? What will be the volume? Now, this is a problem involving number of molecules and volume. Number of molecules. Let's bring the two formulas first so we know what to do. Remember, number of molecules is mass over molar mass times your Avogadro's constant. Okay, like it is given here. And your volume is mass over molar mass times your gas molar volume. So interesting. So interesting. Now because the question involved number of molecules and also involve volume. They said, what volume will this particular molecules of carbon dioxide occupy? So it's a problem involving number of molecules and volume. So we bring our number of molecules here, number of molecules formula, and volume at STP formula. These two formulas will play an important role in solving this problem. So very easy. What do we do? First of all, what do they have in common? Now, what they have in common is the mass over the what? Molar mass. So you can make mass over molar mass, substitute formula here, and substitute into this. So if I call this equation 1 and I call this equation 2, let me make mass over molar mass, substitute formula here. How do I do that? I can divide this equation by the Avogadro's constant and do it here, Avogadro's constant. Remember, this is number of molecules or number of atoms or number of particles, and this is Avogadro's constant. So by the time you divide both sides by Avogadro's constant, you will find out that your mass over molar mass will give us the number of molecules over your Avogadro's constant. So if your mass over molar mass gives us this, it means that we can take this now and put into this one to replace our mass over molar mass here. Okay, so your volume becomes, instead of writing mass over molar mass, we can put this here. We have number of molecules or atoms over Avogadro's constant times your gas molar volume. Wow, this is interesting. So we can solve the question now. Don't forget we're looking for volume. So let's just substitute our values. Volume is equals to, what's the number of molecules there? Look at it. 1.51 times 10 raised to power 23 all over your Avogadro's constant is given here 6.02 times 10 raised to power 23. So interesting. Times your gas molar volume, which is what? 22.4 dm3. Can this value cancel out this value? Yes. So what do we have left? We are left with 1.51 times 22.4 all over 6.02. Let's quickly use our calculator to solve this problem to get our answer. One point 51 times 22.4 divided by 6.02 will give us 5.6. We have 5.66 dm3. That becomes the answer to the volume problem. So the answer is option A. Now we have come to the end of this video. If today is your first time for coming across our videos and preparing for WAEC JAM or other related exam, please do not forget to subscribe to this channel because we have a lot to offer you. Thank you very much for staying with us on the H2O Spirit channel. We're going to see you in our next video.